Hi, this is Dr. Mack, and I want to go over with you very quickly some of the problems here on the take-home final and discuss some of the instructions for you. Now, the due date for this is Wednesday, December 14th. That's a week from this Wednesday at 2:30 p.m. Now, a printed copy is due. I don't need any electronic files. I need a printed copy turned into me at that time. Now here's the instructions. You can either work as a team or as an individual. If you work as a team, you have to select 6 of the problems. Each problem you choose will be worth 16.6 points. If you work as an individual, you select 4 problems. Each problem will be worth 25 points. Now, to receive full credit, you must complete all parts of the problem. When asked to justify or validate your solution, basically what I'm looking for you to do is prove to me that you know your answer's correct. Now, there's a reason behind this. One of the fundamental things you need to take away from this class is the understanding that just because the software gives you an answer does not mean it's the correct answer to your problem. And so I want you to take time to validate or justify your solution. This may include some additional plots or calculations. Now, each problem should begin on a separate page. You can use any combination of MATLAB, Excel, or MathCAD. Now, one of the common questions I'm asked is, well, do I have to solve it in all 3? No, you only have to solve it in one. Okay, but if you need to use MATLAB for one part and Excel for another, that's fine. Now, in order to receive partial credit, I'm going to need to see copies of all spreadsheets, scripts, and MathCAD worksheets. Now, this is printed copies. All charts have to be professional engineering charts. That means they need titles, axis labels, and legends if there's more than one set of data on the chart. Your final answers must be clearly labeled. Now, I am going to mention one thing for teams. Maximum number of students on a team will be, I'm going to limit this to 2 people on a team. Okay, the limit is 2 people on a team. So problem 1, I'm not going to read these all in detail, but give you guys a few hints. This is an optimization problem. A couple of different packages readily lend themselves to this, but what you really need to do is sit down and think this through. Alright, exactly what they're looking for. We've got products, the hours required to make it. For product 1, you have 1 hour on the lathe and 3 hours of milling, and you make $100 per unit. For product 2, you got 2 hours on the lathe, 2 hours on the grinder, 1 hour milling, you make $150 profit. Okay? The next thing to notice is the far right corner, hours available. Well, you can't use the lathe for more than 40 hours a week. So you have to also balance out that, let's say you can't say, oh, I'll make 500 of product 1. There's just not enough hours. 50 of product 1. That's still too many hours for the lathe to be able to handle. And so what I want you guys to do, if you decide to work this, and this isn't as bad as it might seem, I'll give you a hint that if I were working this, I'd set it up in Excel, and I'd fool around with the numbers and some formulas a little bit before I actually try to do the optimization. Okay. Now, as you can see here, deliverables, printout of all software used. I want you to write one paragraph or put together one table summarizing how many units the company should make of each product to maximize the total profit. One of the part of being an engineer is not just getting the computer to spit out the data, but being able to explain what it means to someone else, maybe someone in management. Also write a paragraph discussing the sensitivity of your solution. Okay, how much does the profit decrease if you make one more or one less item than the optimum? That means you'll need to experiment a little bit. There's really no right or wrong answer on this. It's more like how intelligently you can express what you find out. Okay, and you also need to validate your solution, demonstrate that this is indeed, your answer is indeed maximizing the total profit. Problem 2, if any of you are in statics right now, this will look familiar to you. We've got a truss system. Now you're given the system of equations here, and I included the drawing so it would be complete, not just throwing some equations at you. This is a really practical use of the software we've learned. So we got a system of equations. We're given values for F1 and F2. You need to solve that system for those values. Summarize your results, and guys, include correct units, okay? Include the units on those answers. Also, validate your solution. Prove that your solution is giving the correct answers. Problem 3 is a statistics problem, where you have a histogram, mean, mode, maximum, minimum, range, standard deviation. I'm thinking this one should be a cinch to do. The deliverables, a plot of the data. Again, a proper engineering plot, just plotting the data points so you can see how they vary. A histogram of the data, and a table summarizing the statistics on it. Mean, mode, minimum, maximum, range, standard deviation. The challenging part of this is to write a paragraph discussing your conclusions from examining the histogram. And what we're looking for is, well, is this data consistent? Can we say that they all get about the same mileage? Or is there a great deal of variation? That type of thing. So use your engineering skills that you've been developing in other classes. Next question, if a car of this type is chosen at random, what's the likelihood the fuel efficiency will not exceed 22 miles per gallon? Well, with this, you guys aren't required to have taken probability and statistics at this time. So what I'm looking for is not a number, but I want your own opinion based on how the data seems to be behaving to you. Alright, now it's important you answer this question. Your answer will be graded based on how you have it correctly interpreted the data. Again, I'm not requiring numbers on this particular question. I'm requiring engineering judgment. Okay? Problem 4 is another optimization problem. With this one, I would make sure how the units are working out before I try to implement it. Again, when you get something with this many units, this is terrible, I'm giving you guys hints like this, but I'd start thinking MathCAD maybe. Remember that you can use the given find block also as a given minimize or given maximize. I recommend you might look that up, or you could use some tools available in Excel. Problem 5, this is another system of equations. This is a piping system. Alright, a pipe network. In a pipe network, two conditions must be satisfied. The sum of pressure drops around a closed loop must be 0. In other words, the pressure at that point has to be the same no matter how you went through the pipes to get there. And this is just common sense. The flow entering a junction must be the flow leaving it. Flow in equals flow out. So we're given an equation to calculate head loss. That's the loss of pressure due to friction. Okay, the factor F is a function of the relative roughness of the pipe. For this example, we're going to use F as 0.02. Q is flow rate, and V, that will be velocity, equals flow rate divided by area. Okay, CFS stands for cubic feet per second. We're given the flow going into pipe A, out of C, and out of E. We're given the pipe lengths and diameters we need. And you guys are also provided with the set of equations, so you don't have to worry about trying to set up a system of equations. Much like that statics problem, that set of equations is given to you. For this, solve for all unknowns. Make sure you use the correct units. I want to see those results summarized in a table. Okay, not just spread out on a worksheet. And validate your solution. Moving on quickly, looking at problem 6. This one is a company that manufactures and sells golf carts. Read this problem through carefully. I really don't think it's as bad as it might initially look. When I see this, I think of two things. I think of summation functions in MathCAD, and I think Microsoft Excel. Now, you'll have to excuse me. As a young student, much like yourselves, I was brainwashed into thinking all the world's problems could be solved in Microsoft Excel, so I tend to lean towards that. But again, you guys use whichever piece of software you believe you can get the answer with. Alright, that is the most important thing. Excel, MathCAD, or MATLAB, it's your choice, whichever one you feel the most comfortable working in. Okay, now with this, again, I would read through this carefully if I were you guys and take a look at it. Again, it's not as bad as it might seem. You need to produce 2 plots. Again, they need to be professional engineering plots. Validate your solution, maybe calculate a couple of data points by hand, compare them to the graph so you can prove your answers are correct, you're getting correct values. Oh, a curve fit problem. This is stopping distance as a function of initial speed for a certain car model. You're told to find a quadratic polynomial that fits this data, determine the goodness of fit, plot the original data and the curve fit, and find out what that formula is. Use the formula to predict stopping distance for a value that's not on this plot, for a velocity of 80 miles per hour, and then one for 10 miles an hour. Now, when you look at the plot, be able to explain why or why not that curve fit is really appropriate for the data. For that, you're going to want to look at the overall behavior of the data. Remember what I've talked to you about. Does the curve fit really represent how the data is behaving? Okay, so deliverables, print out from all software you used a plot of the original data with the curve fit, formula, and a measure of the goodness of fit. Now again, you can do this in any MathCAD, MATLAB, or Excel, whichever one you're the most comfortable with. You need to explain why you feel the formula does or does not represent the data adequately. Give some predicted values for those 2 points that are not in the data set, and validate your solution. Explain why you believe your solution is correct. Okay, again, moving on. Problem 8. This one is an interesting one. We've got a small rocket. We've got an expression for vertical velocity between 0 and 8 seconds. After 8 seconds, it's going to behave using gravity. V equals V naught minus 32.2 T minus 8 for times greater than 8 seconds. And if I were working in MATLAB, all of a sudden I would be thinking if statement. Okay, I might be thinking that in Excel too, or in MathCAD. We're seeing an if statement here. May or may not require programming, it's up to you. What you need to do is integrate these 2 expressions to determine the maximum height attained by the rocket and how long it took that rocket to return to the ground. And your deliverables, print out from all software you use to solve the problem, a plot of rocket velocity versus time, plot of rocket height versus time, maximum height attained by the rocket, time of impact, and why you believe your solution is correct. So again, let me go back up to the top. You do not solve all of these problems. If you are working on a team of 2 people, select 6. If you are working as an individual, select 4. Email me with any questions that you might have if I feel it's a question the rest of the class needs to also hear, or if it would be unfair for me to just tell you and not the others. I reserve the right to post it on Blackboard for your classmates to see. Now, I want you to email me today with A, whether or not you're working as an individual, and B, who your team members are going to be. Thank you.